neutrino density. We haven't spoken much about neutrinos. We will in the future, but for now, just know they're a particular kind of particle, really tiny mass, neutral charge. A lot of them get emitted when stars go supernova. So the amount of those in the early universe can be tweaked through these parameters as well. Density perturbation amplitude, big words for Elmo. This is the size of density fluctuations in the initial universe. So there were pockets of the universe that were denser than the surrounding regions. And so how much denser, that's the size or the amplitude of the fluctuation. Then relatedly, density perturbation spectral index. So this is the spatial scale of the perturbation. So you have how big is the difference between the dense region and the surrounding space, and then how big is the spatial separation between the dense region and the surrounding space. Then tensor to scalar ratio. This one's really in the weeds. Not going to spend too much time on it. It's a ratio of gravitational waves, which are a ripple in space-time caused by a moving mass, a ratio between that and your density fluctuations that we just talked about, which is just those pockets of space that are denser than the surrounding space. So it's a ratio of those two modes of perturbing and disturbing the early universe. And so that ratio tells you something about what kind of observations you could expect to make if your simulated universe were like our real one, which is ultimately the goal of doing these sims, right? And then finally, ionization optical depth, how far a little light particle, a little photon can go before it smashes into something. So these are the puzzle pieces. There will be a lot more of this series. We'll get deeper into the weeds. It'll be fun. It'll be so much fun. I'm Kishan, and thanks for making space in your day.